All right, welcome to the next in the series of the Fall 2020 Digital Demos. I am Andrew Hart here on the Space Moon surface of Vivian's first year model and the Heliodon in the Seed Center in happier times. We're gonna have a lunar lander landing right about here later on tonight. This digital demo put together by our digital demo assistant, Sal Armetta, with our shop monitor, Drake Schaefer, and an alumni, and our laser lab technician extraordinaire and fifth-year student, Norm Engel. They're going to be going over some common problems and ways to set up using files for the laser cutter and our other 3D fabrication equipment tonight. We're going to be recording this session and posting it out to our YouTube. Please follow us on Instagram. Let us know by either emailing us, poking us, jabbing us, texting us, messaging us, what kind of digital demos you want to have, what kind of ridiculous backgrounds you want to have. If you want to have more open studios with DJ'd music like we did last semester, if you thought that was super lame and we should never do that again, please let us know. And at this point in time, I'm going to introduce Sal, our digital demos assistant extraordinaire, who is running our IG, and have him introduce our presenters for this evening. So Sal, who's presenting this evening?
All right, well, we have Drake Schaefer, the head operator of the Cape Fab Lab, as well as Norm Engel, who is a fifth-year student and one of the main laser lab operators, both of which do exceptional work in model making and have been using these machines for a very long time. Drake, who is very experienced in experimenting with different materials, as well as using the 3D printers a lot. And Norm, from personal experience, I know he has done a lot of work with the laser cutters, both in terms of architectural models and as well as using it for other personal work as well.
Awesome. All right. So, gentlemen, take us away to the wonderful world of 3D fabrication.
All right. So just to kind of lay the groundwork of what we're going to cover tonight, I want to start with a little slideshow presentation showing some past work, showing kind of how I've used 3D printing and laser cutting, both in kind of typical use cases and some more random experimental things I've done. After that, I'm going to toss it over to Norm. He's going to discuss some of his work. I know he's going to talk a lot about some of the laser welding he's been doing recently. And then after that, we're going to talk about kind of setting up, 3D print files, laser cut files, and some kind of common pitfalls, how to work around them and such.
All right, excellent. And just so that we know, Drake, you can commonly be found at the Weber Fabrication Lab and the laser cutters over at Seed. And those are up and operational even during these restrictions. We're still working to have them staffed and be available for students. That's correct?
That's correct.
All right, awesome. Thank you. Take us away.
All right. All right, is the screen up?
Affirmative.
Okay, so for anyone who's not familiar, we have three different types of 3D printers on our campus. So we have the Lulzbot 2 Plus. This is the most common one we have. We probably have almost 30 of these scattered around campus. We have the Lulzbot 6. We have maybe about 6 of these around campus. And then we also have this See Me CNC Artemis. We have 2 of these on campus. Each of these machines are capable of doing, 99% of the printing you want to do on campus. Which one you use is more a question of availability than preference. But let's just jump into this. So probably the most common use for 3D printing is going to be for study models and little iterations. This is one from, I believe, my D5 project. It's this little mid-rise tower with this kind of carve cutting through it. I would say about 85% of the printing that I do is just kind of iterative design process. Let me get this model out quickly, look at how it looks on the site, get an idea for proportion. And just to get the digital model that I've spent, all these hours kind of slaving over into some kind of tangible object that I can really kind of get my hands around. But with that comes a lot of failures, as you can see. If you are not familiar with 3D printing or haven't done it that much, this is a fairly common sight you'll see. You have set a print off for the night. When you left, everything was going perfectly. You come in the next morning and it's just a mess. Sometimes you get lucky and your print will just magically save itself. Most of the time it won't, however. So here's another example from a D6 project. Pretty much all of the filament we store on campus is just this solid white. It's kind of the architecture's favorite color for working in models and scapes. And you find that it can pair nicely with, a lot of the basswood and plywood you get in the school store, cardboard, plexi. It's a nice kind of starting canvas for your designs. We can get other types and other colors and other special kinds of filament. If you are planning on getting any for one reason, I'd recommend coming to me. We can talk about some more specific pitfalls to using specific other types of plastic in the printers. So this is probably a more finished model I've made with 3D printed parts. You can see these massive columns that kind of extrude below and above the structure. Are these 3D printed forms that I finished off with this kind of rock concrete based paint. Here's a little close up of the paint being applied. This was a really fun one because the shape of these kind of fingers, as I called them, really evolved based off of the structure and the form that the house had taken. And I was so used to seeing them in this configuration that shortly after I printed them out, I made sure to take some photos, just experimenting around with the forms and using them in ways I hadn't anticipated. Which is one really great aspect for 3D printing, I find, for when I'm stuck in a design rut. If I'm zooming around a model in Rhino for what feels like 3 years, I can take either the whole thing or portions of it, quickly print them out at various scales, and then just move them around in different configurations to get some new ideas. You can see here, particularly with the photo on the left, these are not high quality prints whatsoever. The layers are kind of shifting. There's way too much space between them. But for this kind of experimental purpose, and then for this experimental purpose, they're fine. And since I was going to paint over them anyway, it wasn't that big of a deal. Here's some more geometric explorations. These were actually done on our resin printers on campus. We still have them. They still work, but they've definitely been pushed off to the side given the current situation, and they're not currently accessible. But if you have something you need to print with a resin printer that for one reason or another you cannot print with any of the other machines, come see me. We can work out a time and a place where we can get the printers set up and running and get your things printed. They require a different setup than the other 3 printers that you'd mainly use around campus. This is a little example of kind of a happy little accident happening. I was helping a friend print these kind of X braces for this large tower he was working on. And we got this really bad stringing happening between the prints. But on the initial prints, we thought, well, there's some interesting properties to this. And so we purposefully tweaked the settings to encourage this extra stringing. And that gave us this nice kind of ghosting effect, which gives this really nice appearance of kind of a glazed finish. And that kind of began some more thought into how can we turn some of the inherent mechanics of 3D printing into other, just other design avenues, I guess we could say. Here's a quick example using under and over extrusions and kind of tapering them throughout a G-code file. You can get more of a hand sketch look. And so I use that to create a set of scale figures based off of how a number of famous architects draw their scale figures. You can see them kind of here just mounted onto this basswood stick. Another example of exploring with that is using, this is a wood-based PLA. I wrote a Python script which randomly alters the print temperature on every single layer. And due to kind of the thermal properties of both the plastic and the wood, you get these color variations between the layers, which gives you this almost like robotically perfect wood grain effect. But I think something like this would be really beautiful if you're trying to make like a rammed earth model. Beyond schoolwork, one of the most prolific uses I've used for 3D printing was creating my own plotter caps. For those of you familiar with plotting, it's always such a hassle. The office is always closed just when you need it. And I thought, screw it. I don't want to wait. I'm not going to spend the money. I'll just, you know, spend a couple hours with some calipers, measure it out myself, and print it. And then one of the last things for 3D printing that I'm going to go over is just a stupid thing I experimented with over the summer with my personal printer, where I basically printed this little adapter to mount a pen to it and turned it into kind of a pen plotter. So this is all using running through Cura, which is the main software we use for generating G-code and actually running 3D prints. I just kind of altered layer heights and the amount of layers printed to create these, 2D drawings on my printer. It was way more hassle than it was worth. There isn't a super useful application for this, but I think just having fun is a really great vehicle for exploration. Going over onto laser cutting, I'm going to try and speed this up. I realize I'm taking a while. This is a model I did for D7. While most of this model is actually hand built, one of the things one of the things that had to be laser cut was the cladding on the side, because the spacing was very critical. As you can see, the spacing expands outward as the structure continues. And so the way I went about doing this was I had actually laser cut all of these boards as kind of one piece with these two side rails. And then highlighted here in yellow, I took score lines and I tripled them up. So the same line was scored about 3 times so that these end guide rails were just barely holding on to the mat board. So this allowed me to glue all the pieces down at once and then just very lightly kind of glide an X-Acto blade over to trim these end pieces off. And you get this effect that looks like individually placed boards, even though they were kind of placed down as like one large sheet. This is the similar model I showed earlier in the 3D printing example. But I wanted one that kind of took apart on each of these floors. And this one is a lot rougher because the way I went about actually laser cutting these walls was I just cut one long strip of these rectangles kind of scored throughout. And then I basically just laid the wall down on the floor plate, glued one wall, bent it on the corner, glued that next section, and then just continued and then trimmed it off as I got to the ends. Here's another model. This one, almost the entirety of the model is laser cut, with the exception of the main stairs here, which we printed out. This was a fun one for a couple of reasons. We ultimately decided to stain the outside because it better reflected what the project would actually look like. But then we decided, instead of just kind of scoring the outside to get the appearance of these battens, I actually went through with a wood burning tip and just really kind of carved deeper into them, to really kind of emphasize those lines, to give much more of an imperfect texture. Because the idea with this siding was it was going to be shoshugiban, so they were going to be this burnt cedar siding, and we didn't want it to look too kind of perfect and mechanical. And so this is a really great way to kind of highlight that. You can see with the photo on the right where the laser cut lines very much kind of deviate from where my wood burner went through. But I really like the way this came out, particularly with the stain and the large scoring lines. I think they help hide the laser edges that you tend to see in models, especially if you compare it to a lot of the interior here, where you have this very stark contrast between the face of the board where the laser went through, and then again with a lot of the sap from the wood kind of evaporating onto the surface. And so adding the stain and the wood lines kind of mask that effect, which is a unintended surprise, but a nice one for sure. This one shows, or this next one is a series of models I did with, or for D8 with my partner Anthony, kind of looking at the project at different sort of scales. So this is kind of the overall view of the project. Each of these little boxes is essentially a row home stacked on top of each other to create this kind of a community with this multi-tier courtyard in between them. And for sense of scale, the mat board base at the bottom, this longest dimension is probably only about 9 or 10 inches long. So this is a fairly small model. But we really wanted to show the siding of each of the units, since this was the only model we had of kind of the overall project. So we actually took an elevation of each of the buildings and converted it into a laser engraving, and then engraved these boxes so we could get the facades to kind of show up with a nice kind of sense of depth to them. You can also see on the side here, we added these finger joints. These are very common to see in laser cut models because they're really easy, really quick to do. And similarly, you can see these little finger dados for where the floor for each of these boxes goes into. And so we essentially laser cut these as like a series. So this, like these 3 units is one box, and then like these 2 is one. Laser cut out these boxes, assembled them, and then kind of hand built the rest. But you can actually see, so these 2 little walls here weren't actually in kind of the final design for the project. These are just little spacers we cut out for getting the height of this platform right. Here's again the same project, but this is one unit kind of exploded in on a more detailed view. This one we did is kind of a pull away section model. And this one, I think there's a couple little tricks that we use with the laser cutter that I'm really proud of. Kind of. So if we zoom in on the pathway, I think this shows a couple of them here. So the walkway is just a single sheet of the plywood or basswood from the store, but then all of the lines in it are scored in to give the appearance of kind of a multi-board construction. It's a fairly common thing you see. But then these platforms were kind of held in by these I-beams on either side. And so we kind of toyed around with the best way of building this, because as you can see, they curve, especially here, very tightly. And what we ended up doing was just using a variety of thicknesses of sheet goods. So the top and bottom flange are 1/16 inch basswood, and then the web in the center is just 1/8 inch. And this allowed us to actually cut the curves cleanly on the laser cutter and assemble them, rather than kind of cutting a flat surface and having to bend it into shape. The opposite approach for that is what we ended up doing with the handrails. We could have done a similar approach to the I-beams, and we went back and forth on doing that. But given we had to throw these posts in, we ended up just cutting straight segments and then placing them along kind of where they would fit along the I-beams. And while when you get really close, it's probably not the best appearance, when you look at it from further back, you hardly even notice. You can also see that the little facade rain screen, whatever you want to call it, is one piece of plywood with just the geometry cut out of it and then layered onto another stack to give the sense of depth. And then lastly, zoom in on the kind of units themselves. This one you can see explores various materials in its kind of final construction. So these are just kind of simple, simple beams, laser cut out. The screens or the shutter screens cut out as one piece. But I think what I really like is kind of the detail we put onto the interior of the window. So the unit model came apart to show the assembly in its entirety. And so again, we kind of scored the lines to show the CLT construction that we used for the assembly. But given that we did a CLT assembly for the model and you need kind of special window assemblies to kind of fill them out, and we wanted to kind of show that in this model, we basically took the drawing of the window, splayed it, flattened it out, and then just used that as an engraving to show that detail fairly quickly on the inside, because it wouldn't really be worth the effort to show every single small bump and crack, especially when the difference in those layers is very, very minuscule. But I think it kind of shows the intent. It didn't take that long to set the file up or to actually cut, and was kind of the best solution for that case. And that's mostly it. I'll hand it on over to Norm, let him discuss some of his work.
Yeah, so I figured I would show you guys some of the stuff I've been working on for this previous semester, mainly because it's a little bit different than my normal workflow. Kind of my driving flow for the laser cutter is measure twice, cut once. You hear that a lot for like in the wood shop a lot, but same thing applies to laser cutting. It just makes it a lot easier because the worst feeling ever is kind of getting a model assembled like 9% and finding out that that one piece that you need is the wrong size. So just some context for what I'm working on right now. I'm currently in design 9 in the material prototyping section. And we're working on the solar decathlon. Our university specifically is on the facade team. So what I've been doing is prototyping this kind of ETFE facade. It sits and kind of lives over a green wall. So kind of the goal is to have it inflate to close off the green wall when need be, and deflate and kind of open up to allow airflow in when need be. So here's some of the prototyping I've been working on. Kind of the first step was figuring out how to actually weld plastic. And that's something that me and Drake kind of figured out a couple weeks ago. Pretty much what we had to do was kind of mess around with the laser cutter itself. We had to take off the focusing lens on the laser cutter. And what that kind of allows is for us to use the laser cutter in a similar way to where you're cutting it, but without that focusing lens. Instead of cutting it, the plastic, it kind of melts it and binds it. And what that does is creates an airtight seal, which kind of allows you to do stuff like this, modeling that ETFE inflation. So that was kind of an earlier iteration of the model. I have a couple others, but here's a video of the process of actually welding plastic. It'll load up. Give it a second. There we go. So what you're kind of seeing right now is 2 layers of plastic. It's polyethylene. It's those big bags that you buy cardboard in the school store. They come in that. But pretty much what you're seeing right now is the laser cutter following a hatch pattern that I used in Rhino, and it's just kind of sealing it. The seam is about 1/4 inch. When we first started, we had to use a 1/2 inch, but kind of just through testing and prototyping, I was able to get it down to 1/4 inch. So this was kind of just a test print for a kind of sleeve shape. But yeah, just a rectangular shape. So if you notice in kind of this these prototypes, there's kind of this structural piece that runs vertically and horizontally from inside the triangles. So what that's kind of doing is it's what kind of keeps that form of this like curved form when it's deflated. And then it's like what's kind of determining how these panels are moving and stuff when they're getting inflated and deflated. But the process of kind of creating that sleeve is, this right here. So to kind of get that sleeve to hold that structural piece, I needed to figure out a way to kind of weld this like outer sleeve on. So this is what you're seeing right here. Pretty much what I did was I scored the plastic sheet to kind of figure out where I needed to attach these long rectangle pieces, and then kind of taped it down. You also see that like there's this cardboard frame around, and what that's doing is it's kind of keeping the polyethylene from moving around from the suction that's in the actual laser cutter. This is just me kind of going back and trimming it up. There is some kind of leeway room, and then this is just kind of demonstrating it sliding into that sleeve. And then after this, it would go back into the machine and kind of redo that. It would be used as the bottom sheet for that top sheet to get welded on, and then that triangle form would be created from it. And then I'll just show one more kind of update of the module for you guys. This is a more recent one, so but kind of this workflow this semester has been really interesting because, like I was saying earlier, measure twice, cut once. But with this kind of repetitive kind of prototyping, I've really been able to kind of delve in and focus in on like certain aspects to progress the model forward. So it's been a real interesting study into the stuff I've been looking into. That's about it for all I have. So I can hand it back over to Drake, who I think is going to go over some 3D printing and laser file setting up.
Thanks, Norm.
All right. Let me back to the screen. And feel free to interrupt me with questions, clarifications as I go through things, just so everyone can kind of understand what's going on. So I'm actually going to use the same D6 model I showed earlier in the presentation. I'm going to start by showing kind of how you would set up 3D prints, going in through using Cura a little bit, and then we'll use the same thing to set up a quick kind of laser cut file. I'm going to be doing this through Rhino, since that's kind of what most people use for 3D modeling, and it's probably mostly what you'll be used for setting up 3D prints, or at least for getting it over into Cura and getting your prints set up. For laser cutting, you can certainly use Rhino. I think a lot of people use CAD because they have their 2D drawing set up in there. It's a very similar process regardless of the programs you use. So you can take kind of the general advice I'm going over and apply it to CAD, for example. And I'll make sure to highlight where CAD would be slightly different in this example. Some people have even come in with Illustrator files, and we've cut from those. Any vector file basically is capable of being cut on the laser cutters, and really any image file is capable of being engraved. But we'll get to that in a bit. So the first thing, and certainly one of the most critical things when you're converting your file over for 3D printing, is you need to change your units. So to do that, we'll just simply type units, and this little dialog box pops up. And we want to change our units into millimeters. All of the 3D printers, well, I should say Cura runs best, or runs using millimeters, because we're going to convert this into an STL, which is a unit list file. So when you send a model over, it's not 5 inches, 5 millimeters, 5 miles. It's just 5 units. And Cura automatically interprets those units as millimeters. So the easiest way to get around this is to simply change your model into millimeters. It's always a good idea to kind of get your model to the point where you're ready to print, and then just save a second copy as, working model 3D print or something along those lines. So you can set your units and change your scale without affecting your kind of full scale model that you would use later on for grabbing drawings or doing renderings or the such. So change the model units over to millimeters. Display precisions. You might adjust these for model making, but that's kind of outside the scope of this talk. So hit OK. It'll ask you to change if you want to change the scale. If you've built your model in kind of to its full size scale, which pretty much all the time you do, you'll hit yes. So 99.999% of the time, the answer is yes. And of course, your object will disappear once you can't find it because it has changed size so much. So now we have it scaled down into millimeters. The next thing we want to do is to set up a little box for what we can print. So all of the machines have a specified printing volume that they can print, and we want to make sure all of our pieces sit within that. And since I had the page for Ultimaker and Cura set up, I'll just assume we're going to print off of one of the Ultimaker 2s. So you would simply just kind of Google which of the printers you're using, and then add like specs or some other kind of buzzword off the side like that. And for all of the printers, you'll find a little tab saying like build volume or something along those lines. And you can see here with the Ultimaker 2 Plus, we have a build volume of 223 by 223 by 205 millimeters. So go back into Rhino, and I'm simply just going to make a cube that size. 25. Oh, my bad. 223. So that's our build volume, and that's our model. Now, of course, this is still at its full scale. We obviously have to scale it down to however we want, whatever scale we want to print it at. So the simplest way to do that is to grab your model. Make sure you do not grab this cube if you've already drawn it. We're going to start by scaling it down 1 to 12. This just puts everything down into inches. And then we'll try 1/8 this working example. That object was stuck in a cage. That's why it wasn't scaling correctly. So move this over to our reference volume. And you can see here we could probably just about fit the actual building into the total print volume here. Yeah, just about. Okay. So now, of course, we want to get rid of everything we don't want to print. So I'm going to clean up some of these side objects that have been floating around, any of the terrain pieces. And so now we have just the actual kind of building itself. In this situation, I don't want these little glazing pieces printed. So I'm just going to grab them and get rid of them. You can just hide the layers if you want. Totally up to you. Beyond that, I think I'll leave everything as it is. And if this gives us any troubles later on, we can address it. So now, the next thing we want to do is check for any open surfaces or open poly surfaces. If you're having trouble when you're importing a model, 90% of the time, this is probably what the error is. For anyone who's not too familiar with the concept of kind of open poly surfaces, if I just draw a standard box in Rhino and I go over to the properties tab here, you can see this is a closed extrusion. Or if I click, like this object, for example, it's a closed poly surface. This means that the model is what's considered watertight. So all of the faces, all of the edges of the faces meet another edge of a face without any openings or without any kind of manifold edges. Not strictly, but usually Rhino will also tell you if there are those. But you can see a situation where, you know, if I have this top face removed, I now have this open poly surface. And while any of us looking at this would be like, well, clearly you want to print this as a box. The 3D printers aren't always capable of making that deduction. So to them, they're not sure if this is, here's a box, I want to print it as a box, and everything outside of it is open air. Or I want to print everything outside of this box is something I want to print, and this box itself is open air. Sometimes it'll guess it right, sometimes it doesn't. It's always best to check if you have any open surfaces and to either get rid of them or to close them up if you can. So one of the quickest and simplest checks is to just simply do cap. And if you have any kind of planar openings, this will automatically fill them in for you. So to check for those quick, we'll just do cell open poly surface. We don't have any in this model, or we can do cell open surface. Nope. And lastly, we will just do select surface. No. While we're at it, we can just select any curves as well and get them out. They won't have an effect on printing. They don't really come out in STLs, but might as well clean them up. Similarly, if you have a separate 3D print file set up from your main file, which again, I recommend doing. It's also a good idea to purge, which is just a command. This gets rid of any unused data. It's a good practice because once you're transferring things over to the STL, some of that data like layers or like line weights or materials or whatever can get added onto it, which is just taking up unnecessary space in the file size. So not a bad thing to check for. Okay, so now that we have a model and that model fits within our box, or does it? It does. Another thing you can do if you don't want to actually work inside of a box and you can't see your work, if you type silhouette, this will give you all of the outside curves of your object. And so this will give you an idea of how your print comes up. Now I'm going to export this as a print right now. Don't do that. This would be a terrible print as it is right now. And I'll go over that once I export it over. So I'll just grab all the geometry. I'll type export. We will set this over as an STL. And we will just set this as, we'll just do digital. You might get a box that pops up about mesh export options with tolerances. Typically, you can just leave this as it is. Doesn't make a big difference. It'll do some compiling. You'll also get this export about which file type you want to use, binary, ASCII. Again, doesn't really make a difference. Usually binary is smaller, so just select that one. We'll hit OK. And we can see file successfully saved as DigitalDemo 3DPrints. So now we will hop into Cura, and to give you a sense of what Cura is like when you first open it, I've gotten rid of my configuration settings. So this is more or less what Cura will look like when you open it up from a fresh install. You get this welcome message, just hit accept, OK, agree, all that. And then you'll get to this add a printer section. none of our printers on campus are set up, are connected to the network. So everything is a non-network printer. So we'll go to this drop down. And then from here, you'll select which printer you're using. Since Cura is made by Ultimaker, all of their machines are kind of what they put up into the forefront here. But as you can scroll down, you can see they have an exhaustive list of manufacturers and different machine settings. All of the machines on campus are available through Cura by default. So you can just go into here, add them in, and then you can use them. So we'll just do Ultimaker 2 Plus, hit next. And we don't really need an account for what we're doing. And so it pops up as a little display of the printer itself and kind of the volume you're working within. So what we want to do is get our model set up. Let me just browse for it. And there we go. So as you can see, just like as we had modeled in Rhino, the entire thing fits. Now let's just leave everything as default and let's slice this and see what our print looks like. Two days, 11 hours, 37 minutes. That's pretty bad, especially because this doesn't have any supports in it as well. So let me go over that a little bit. So after you've sliced it, this preview window will let you open it up. This lets you kind of examine each of the layers that print. By default, the color scheme is set to material color, but I always like to set this to line type. This gives you some more information about how the print is actually running. So this is bad for quite a few reasons. The main way the printer works is pretty much like a regular kind of inkjet printer. No, kind of any way like a pen printer would work. The layer is kind of drawn out one line at a time, and then it closes in and fills out the geometry on a layer at a specified layer height. And once it does one layer, it moves up, does the next, and continues that process upward through the model. So the big problem for this file is this second pillar over here. It's impossible for it to just start in the middle of the air like this. It has to have a support underneath of it because the plastic has to fall onto something. So the main way you would get around that is by checking this option called support. This adds kind of very thin temporary walls to any overhang or unsupported surface of your model to allow it to print properly. But as you can see, it adds some more print time. And for something this big, a drastic amount of time is added to the print. So you can see here, because of the deck surface, all of these blue lines are just supports, which is just plastic that we're printing only for us to take it out later. And not only does it add into the deck, but even on the interior of the house, it gets added. It adds time, it adds weight, it adds material, and it adds the massive headache of trying to clear all of that material out.
So, Drake, can I ask some questions?
Go ahead.
So to like troubleshoot a model like this, rather than trying to do it all in one go, especially if you don't have the supports you showed us a picture of like what a project looks as it like melts and prints on the deck.
Right.
Could you cut it across that main red planar axis and at least print it up from, like print the bottom part from the middle to the bottom, and then upwards, like cut it in half, flip it on its sides, and then build it like a layer cake later,
Yeah.
rather than trying to do like everything at once, or like break it into parts and like lay it out on the deck and have it print, in 3 pieces instead of all in one go.
Absolutely. That's what I was going to get to. Is kind of how most of the time you don't really want to print an object, especially a larger final scale model, as one piece like this. So this is at 1/8 scale, and this is a small, this is only like an 800 square foot building.
Yeah.
So printing this at 8 scale is doable.
Gotcha.
Doing your large tower projects, that's way outside the scope of this.
And maybe just because you can print it on the printer doesn't mean you should print it on the printer.
Exactly. Now,
like I'm looking at those ribs, like those 4 ribs could even, like, you could use the same file. So rather than having to clean up the file 4 times, you could print it 4 times laid down on its side, like one of those big kind of D-shaped pillar things.
Yep. So I'll get to that into a bit.
Sure.
Now, if we were printing this at, like, say this was a quarter of the size and it was only this big.
That's a different ball game.
Yeah, something like this for sure. Set it up, let it add those supports. 4 hours for this entire print. It's going to be annoying cleaning these supports out, and as you can see, these outside walls didn't fully come through, and they're really only about as thick as these supports. So you're probably going to get parts breaking off. But it's something at this scale and at this quick of a speed, it's fine that it's broken because you're using that to learn. Certainly you don't want to be doing that when you're maxing out the entire build volume of the printer. So how would we go about printing something like this? So again, I think the main thing you would want to do is break this up into kind of discrete bits or parts that we can print out. It's only going to make it easier to print. It's going to cut down on the supports. It's going to use less material. It's going to take less time. It's going to be less of a headache to clean up. Plus, when you print it in multiple pieces, you can change the orientation of those parts so that they're printing in kind of the best way you would want them to print. For an example of that, say the only way this kind of full-size model would fit is if it was lying on its side. That would be kind of the ideal way to print these side columns, so they come out as one clean line. But just because that's the best orientation for that single piece doesn't mean that's how the whole thing should be printed.
What's the best way to slice it up so that it maintains that water tightness that you were talking about before?
So the first thing I would do is, so in this model, things are like discrete elements. This isn't one kind of poly surface. It's
right
400, like 43 or something like that.
Right.
So the first thing is, if you can avoid actually kind of trimming or bullying any geometries, start with that. So in this example, these pillars are all already discrete watertight elements. So these can be kind of pushed off to the side. Same with this one. Similarly, the kind of joists that are hanging out here underneath the deck could be moved over. Now, since these are flat elements, it might be better to laser cut these. And that's what I ended up doing on the model that I actually built for this. But if you wanted to keep the visual consistency of having all of your pieces be 3D printed, it wouldn't be a problem. And these are small enough in thickness that it's not really going to take that long to print out. Anyway.
Sure. But like diversifying by breaking it up rather than trying to compose it as a total model. I mean, there's two things that are happening here. You're diversifying your prints, which means that if one thing fails, you're reducing the chances of everything failing because you could just reprint a part instead of the whole.
Mhm.
And then, the other thing that's interesting is like, it also means that it's recursive, like it's teaching you how to make a better model, but also a better architecture because you're thinking about components, repeating parts, and that lends itself to just a better design language too. I mean, like the 3D printer actually designing for a better 3D print is actually going to give you a better design rather than just making the 3D printer print the wild, crazy shapes.
Oh yeah.
Yeah.
I think it's always a good idea when you're working on a design to keep. A lot of people talk about kind of like the scales of like the micro, the macro, and like the meso when you're working on a project.
Yeah.
And I think keeping that in mind with construction is also a very good thing to do with design. So not only thinking, how is this building actually going to be built, but even on the small scale, how am I going to build the model of this?
Yeah.
Because a lot of the model building techniques and systems you would use have almost direct counterparts to the actual kind of construction of the project.
For sure.
So it's a lot easier to have those in mind than to come up with this crazy form, this crazy building or whatever, and then think, okay, now I need to figure out how I want to break this into discrete units that I can build. So simply breaking this up into these sections here would do quite a lot on cutting down print time. So with these 4 columns, for example, instead of printing them up, I can now take one, lay it down on its side, and then kind of nest these within each other. And I can find some kind of configuration that fits within the printer to print these out.
That also saves time because then the printer isn't spending a lot of time moving the head around, not printing.
Yeah. And when you're printing, obviously the bigger a model, the longer it's going to take. But in general, the Z-axis is what adds the most time. Certainly, if you have a very complex footprint, that'll add time to it, but not as much as if you're printing something massively tall.
Gotcha.
So not only like with this column, for example, printing it standing up like this would be the worst orientation in terms of print time, because with this massive beam that extends from it, this all needs support. It has a large Z height. It's going to take a while to print. Flipping it upside down is better, certainly, because now this beam doesn't need any of that support added on, but it's still a fairly tall print. And then, of course, printing it on its side, now we only have the little bit of support in this kind of chamfered area, and we're drastically reducing the Z height. Now, granted, I think this printing vertically might be aesthetically the best choice, but that's such a minor detail, and one that typically by the time people are making their final models, the clock is already ticking.
Yeah.
And a complete model where your layer heights or your layers are printed in probably less ideal orientations is much better than, just having your columns printed because they took 3 years.
Right. Yeah. It's much better to have kind of a stable material for the model. It's much better to test it, to break it up so that it's more, I guess we could say, resilient. Means it is a lot better. It's a lot better practice. And it also means that you get your model sooner. You can start putting stuff together sooner. You can encounter the invariable questions and oopses and, oh man, I wish I did this earlier rather than later, which is always good.
The other reason I would avoid printing this vertically is if we're talking about the strength of your prints, between layers is where prints are the weakest, because you just have a semi-melted layer of plastic sitting on top of another semi-melted layer of plastic. And so it's very easy for the print to delaminate between layers. Whereas if you tried to break it along layers, it's a single solid extrusion you have to break. So with this, you're also adding more kind of points of failure.
So the 3D printed models, it's almost as if they have a grain just like wood, and there's a plane of weakness. And that weakness is like with concrete, if you pour concrete on top of set concrete, there's a plane of weakness between because it's a cold joint between the semi-melted pieces versus the extruded singular piece.
Exactly.
Yeah.
And granted, for most prints, the structural integrity is not that big of a deal.
Right.
Really, that's only going to be a question of, if I drop this print,
right,
where will it break? Or
if you have something that's really delicate that needs a lot of supports, the more supports means the more stuff you got to clean out, which is the more force that you're going to exert on the model while you're cleaning it and things like that.
That too.
Yeah.
Those kind of questions, they're really good to address if you're using 3D printing to build a tool or to build a device to do something else that you need.
Right.
Which certainly you'll do kind of later on in your career. But for model making, not the biggest question.
What kind of tools do you use to clean the prints after they're done?
Very good question. Most of the time I use thin kind of like wire snips. So it's essentially just like a pair of like needle nose pliers, but they come to a point and they have a sharp edge to them.
Mm-hmm.
Those are good for cleaning along the surface, like where your supports actually meet the model. It's also good to have a set of just regular needle nose pliers for if you have large sections of support, just to pull those material off really neatly. X-Acto knives work really well. If you want to go out and spend the money, there are plastic chisels, which work really great. But most of the time, an X-Acto knife for a box cutter, some kind of, needle point like clippers or snippers, and, a good pair of pliers get you most of the way through.
So let's just talk logistics for a little bit in terms of the laser cutter and the 3D printers. What kind of training do students need to have? Or what familiarity do they need to be doing if they need help getting their files prepped, especially right now with the COVID restrictions on campus? What's the best way to get Q&A or just a quality check if they're having issues or need training? They should get in touch with you, reach out via email, bump you on Instagram. Like what works best for you, Drake, and for you, Norm, for what you guys are doing if people want to hear more about your crazy laser welding?
So certainly I think, reaching out to me through my school email, I try to check it as much as I can, but, working in the shop, sometimes I don't check it for, a couple hours.
Mm-hmm.
Or, if you find me on Instagram or something and you reach out to me that way, let me know kind of why you're reaching out to me. If I get, a DM on Instagram
that says, "Can you help me?" doesn't mean anything. That's kind of creepy.
Like, exactly. Like, give me some context so I can go, okay, that's what we're going through. I would probably prefer email just because you can kind of give me a more succinct sense of the problem, and then
we can track back. We can track the email and the issue. You can attach a file or a screen grab, which is a lot easier, probably.
Certainly.
Yeah.
And if it's a small thing, I might just be able to kind of be like, point out the error, shoot it back to you. If it's something more involved, we can set up like a Zoom meeting or whatever, and do some screen grabbing that way.
Awesome. I was going to say, that's one of the things which is like, it used to be that you needed to set up an appointment and come in. Now you can just coordinate an appointment and log on to Zoom and get help live from your computer screen to computer screen. So that's actually kind of a good thing. I think we'll keep that no matter what. How about the laser lab for signing up for times in the laser lab and managing that kind of stuff?
Yeah. So setting up appointments for the laser lab at the moment is still done in person.
Okay.
Simply because you have to drop off your file on like a USB, and you have to bring your material to the shop. So we don't have like a fully remote system for that. But you're able to come in anytime the shop is open. You don't have to kind of set up a prior appointment or really even interact with anyone. Just come in, fill out the form, drop your material off, and then we can get it cut, drop it back off on the shelf, and then you come back, pick it up.
What do you guys think? What do you guys think are the most common reasons you see in the laser lab for a file failing or taking too long or not finishing the way that a student wants it?
Okay, let's go over that for a bit. So really quickly, setting up a laser cut file is essentially setting up 2D line work and using specified layers for doing each thing. So what you'll typically do is set up kind of a box that represents the material you're using. You want to constrain this to the the dimensions of your material. It's also a good idea to give yourself kind of an interior border of about 1/8 of an inch, 1/4 of an inch. Because when you buy like the plywood from the school or you buy a sheet of mat board, it's never 12 inches by 24 inches. It's always, 11 and 27/32 by 11 and, 29/32 or something like that. So anytime you try and cut directly to the edge, you lose the fidelity and the accuracy of your pieces. So it's always good to leave a frame and to cut your shapes out so that they're exactly the dimensions you need. So I'm going to quickly set up some layers. The basic premise for these is you'll have a layer for cutting, which has a red color to it. You want to make sure that it also prints in red, and it has a thickness of, if you're doing it in Rhino, you'd use hairline. If you're doing it in AutoCAD, just set it to 0. And make sure it's continuous, doesn't have any kind of dashing or dotting to it.
Okay.
And then for scoring, it's exactly the same except you use blue. If you're setting these colors in AutoCAD, you when you pull it up, it'll give you the kind of swatches. There's kind of the large box, and then there's like the smaller set of like predefined colors. You want to use those reds and blues. The machine's very specific in that red has to be 255/00, blue has to be 00255. So use the swatches. Don't kind of pick the colors out of the air. So common things we see with laser cut files that take a long time. One common one is, let's say you're cutting out a big grid of squares. Now, first off, if you are cutting out squares and what you're keeping out of the squares, maybe the laser cutter isn't the best tool to use.
He speaks the truth.
If you have a very specific case where you need 330 tiny little squares, and it's the only way you can do your project, sure, we'll figure something out. But if you're coming into the laser lab to cut one big block out of your sheet of plywood, you're not kind of using the shops correctly. That's not the most efficient way of doing this. But for this example, let's say you're cutting out, you have a grid of something like this, more or less. Now, if what you're keeping is the exterior grid, say this is maybe like a building for context and you're showing like the windows, or it's a slab system of some kind, there really isn't any kind of optimization we can do there.
If
But-
you want to have the spaces between the squares, if that's the objective to keep.
Right.
But if you want the squares, there's a ton of wasted material right now.
Yeah. So if this was the CNC machine, we have to leave the space between all of the objects, because we're using, you know, a router bit. It has a very kind of definitive curve to it.
Yeah.
Something you're probably familiar with if you've been in the wood shop, and you know, you draw all your lines for your floors and your walls and your plywood, and you cut exactly along those lines. You put your pieces together and things aren't lining up. You have to keep in mind that every tool has a thickness to it you have to account for when you use it. The laser cutter is pretty much the only exception to that case. The actual width of the laser is negligible for what we do. So what that means is, in a situation where we have a group of objects like this, we don't need to leave space between them. We can grab them and just butt them up against each other.
Can we optimize that further? Because the laser is still going to trace each and every square, but one of those tracing is going to cut out two sides.
Yes. So this is the first step. But if you don't make sure to clean up your lines later, that's where the big problems arise. So this is actually easier to do in AutoCAD. You would simply grab all of your line weights and you would just do overkill. And what overkill does is it'll take like this center, for example, and it'll kind of mark this as one line. And if there's any line that intersects it but never goes outside the bounds of the line, it'll just get rid of it.
Nice.
To do that in Rhino, it's also very simple, but it's a little different. You would just grab it and just do a make 2D.
And that compresses it into way fewer
single layers.
Into single layer pieces.
So when you do this, you obviously want to make sure you're in top view, have the view selected. You want to set options to maintain source layers. This way, your cut lines, your score lines will stay together, and they won't clash with each other. So they won't accidentally kind of you won't get rid of any score lines because there's a cut line overlapping it, which most of the time I don't see a reason why you would have a score line overcutting a cut line, but I'm sure there's a reason you might want something like that. You wouldn't want tangent edges, hidden lines, or scene silhouettes selected. Really, any of these options you don't really need. So we'll do the make 2D. Here we go. So you can see here we have 4 curves here, 4 curves here. Ah, no, this didn't do it. I forgot to do a step. You have to explode your curves and then do make 2D. And now it should work. Or I am not selecting something properly. We will find out. Now you have 12 curves. Okay, that's better. So you can see with this exploded, here we have 2 curves, but here we only have the 1. Which, as Andrew kind of mentioned, because we have 2 curves overlapping here, this means that the laser is going to follow this curve and then come back and hit the second curve. Which, again, most of the time you don't want, unless you're doing something very specific. But it's better to kind of clean those lines up. So you can imagine how if we were cutting, 200 of these out, saving 4 extra lines or saving 1 extra line per box makes a huge difference.
Sure, it's going to make it go 25, 50%. I mean, even if you can reduce the amount of lines even more, and you can make it, like you were saying, in AutoCAD in a grid where the laser isn't constantly changing directions, but it just does rows. If it can do rows and then go back and do it, it can probably print it out. You can probably optimize this to print out in 20% of the time that it would if you were just cutting the squares. And you end up with the same shape, the same quality, but it goes a lot faster.
So that's a good point you bring up, because this is something most people don't do. I'm guilty of that myself. So since each of these kind of units is a distinct line, the laser reads them that way. And I've been working with these machines for about 5 years, and I have yet to figure out how they order which lines they cut. I know in general, it tends to cut interiors before it cuts exteriors.
Gotcha.
So it'll cut your windows out before your walls in general, but that's not always true. And in a situation like this, where there is no clear inside outside, it's very possible the laser might cut this line, jump over and cut this one, come back and maybe cut these 3, cut these 2, cut these, and then cut that in that order. Like, who knows? So it would be a good idea to combine your kind of major axes. Like grab these, join them into one curve. Grab these, and do it this way. So you minimize the amount of times where the laser could follow a line, stop, hop somewhere else, and then hop back to finish the line. Really good point for bringing up.
Cool. Hey, Drake, I'm realizing there is a ton. I mean, there's a ton of finesse and pieces in here, but we've been going for a little bit of time. So I was wondering if maybe we can wrap for now. We can always do this more.
Mhm.
I was just wondering what kind of questions or feedback people had. And also, since we have a small group, I think it's a good opportunity to get some thoughts about, we've got first, second, fifth year represented here, fourth year represented here. I think it would be great to get some feedback on as we're planning demos, because one of the ways that I plan demos is by hearing from everybody on campus, but that's not happening this semester. So I was also wondering about that. What do you guys think? Any specific questions for Drake? Norm had to head out. All right, I'm gonna hit stop on the record.